For under number system. Classify the following numbers as rational or irrational. The sum is 2 minus root 5. The value of root 5 is 2.236 and so on. The value of root 5 is found using the long division method. Please refer to the given link where I have discussed the prerequisites which are needed, where you can see how to find the square root of numbers. So substituting the value of root 5, you get the value 0.236. If you look into the result, it is non-terminating and it is recurring, so it's an irrational number. The second sum, it's very simple. The resultant is 3, it's a rational number. Third sum, 2 root 2 divided by 7 root 2, it gives rise to 2 by 7, it's a rational number since it is in the form 2 p by q. Find the value of 1 by root 2. Now the value of root 2 can be found by using the long division method, and the value comes out to be 1.414. Please refer to the link below in case of any doubts on the long division method on how to find the square root of any number. For this problem, we multiply both the numerator and denominator by root 2. And simplifying, we get the value 0.7071, which is a non-terminating recurring decimal. So it is an irrational number. Next sum is how do we find the value of 2 pi? The value of pi, as you can see, it is 3.1415. Now 2 pi is just twice of it. It is once again a non-terminating recurring decimal. So it is an irrational number. Simplify each of the following expressions. The first number is 3 plus root 2 times 2 plus root 2. Just follow the identities that are being discussed and you will get the answer as it is seen here. The next sum is 3 plus root 3 into 3 minus root 3. This follows the identity where a plus root b into a minus root b is a squared minus b. Following this, you get the value 6. The next problem is root 5 plus root 2 the whole squared. This will follow the identity a plus b the whole squared. If you just replace it in the formula, you get the value 7 plus root 10. The next sum is a is of the format a minus b into a plus b, which is nothing but a squared minus b squared, the value of which you will get it as 3. Earlier in chapter 1, you have learned how to find root 2, root 5 on a number line. Now the question is how to find a number with decimal expansion on a number line. The given number is root of 9.3. How do you find the solution? By choosing the right constructs, you should be able to derive root 9.3 as a resultant and use it on a compass to mark the measurement on the number line. Now, how do you incorporate the identity in this derivation? By using the Pythagoras theorem, you construct a triangle with one leg being root of 9.3. Draw this triangle inside a circle where the diameter is 1 more than the square of the given number, which is 1 plus root of 9 plus 3 squared, which is nothing but 10.3. The diameter is 10.3. Now you construct a circle with radius 10.3 by 2. Identify the radius as OA, which is equal to OC, which is equal to OD from the diagram, which is equal to 10.3 by 2. From the point D, drop a perpendicular to the diameter where it makes a right angle at point B. You can understand from the diagram very well. Look carefully. ODB is a right angle triangle. Now, we can make use of the Pythagoras theorem. We need to find OB. OB is nothing but OC minus 1. Follow the derivation as it is given on the slide. And hence OB is nothing but 8.3 by 2. Now BD squared is equal to OB squared minus OB squared. Which is equal to square root of 9.3. This you can find out from the derivation as it is given. With D as center, take BD in the compass and mark E on the number line so that BE will become equal to square root of 9.3. That's how you derive 9.3 on the number line. Now, why are we using square root of 9.3 squared plus 1 is equal to 10.3 as diameter? Only then we get the radius as 10.3 by 2 and you can use this measurement as the hypotenuse. Also, only when you use 1 in the identity x plus 1 into x minus 1, which is equal to x squared minus y squared, where x can be replaced with 10.3 by 2, y can be replaced by 8.3 by 2. Now the difference between them gives 1 and the average between them yields the number 9.3. Now we are deriving 9.3 as a resultant using the Pythagoras theorem, and hence making use of the measurement BD, you construct a point on the number line. The point where it meets the number line is E. BE is equal to square root of 9.3.